Hello, today we're going to be talking about prime factorization, which is one of the cornerstones of pre-algebra or of elementary school math, essentially. So what do we mean by prime factorization? It's this idea that you could take a number and break it down into its prime factors, right? So before we understand prime factorization, it might make sense to understand what is a factor, what is the product, and what is a prime number. So why don't we start from there? What is a factor? One of the best ways to understand what a factor is actually to think about this question. 3 times 4 is 12. Now notice that I can put a dot in between, or I can write it like this. 3 times 4 is 12, okay? 3 and 4 are the factors, okay? So they're called the factors in this, the factors of 12. Now, 3 is a prime number. We'll talk about that later. 12 is called the product. The product is this. This is 12 is the product. Okay, so 3 times 4 is 12. The number 12 is called the product, while 3 and 4 are called factors. So if somebody says find the whole number factors of 21, for example, we take 21, and we know that 21 is 3 times 7 is 21. 21 times 1 is 21. So then what are the factors of 21? Well, the ones that I just underlined. 3, 7, 21, and 1. Those are the factors of 21. One of the best ways to be able to break numbers down is, and to do prime factorization, is to understand something called divisibility, right? Divisibility involves breaking a number down. And I know we're talking about a lot of big words here, but what to keep in mind is that there is a way to know what numbers go into what. Let me give you an example. 21 here. 21, 2 plus 1 is 3. Whenever you add the digits of a number together and they give you a number, that number being a multiple of 3, which in this case is just 3, right? 2 plus 1 is 3, means, so this means that 21 is divisible by 3. Okay, so that means, or this means that 21 is divisible by 3. So one of the things you will learn from this section of our book, from 1.4 on prime factorization, is divisibility rules. And we also have this in our book, Tools for Mastering Mathematics. There are ways to know if a number can be divided by another number. So for example, 242. Is that divisible by 2? The answer is yes, because it ends with even number. Okay, so it ends with an even number, so it's divisible by 2. That means that 2, if you divided this by 2, you would get an answer without any remainder. That's what that means. Okay, so divisibility rules are very good and helpful. We have a list of the rules for you in this section. We have it, as I said, in Tools for Mastering Mathematics. But before we go further, why don't we talk about prime numbers? And there is a way to discover more and more prime numbers, but why don't I just give you the first few prime numbers? So 1 is actually not a prime number. It's neither, 1 is just 1. It's not a prime, okay? The other word we use for numbers is composite numbers. Those are numbers that are divisible by other things other than themselves and 1. Prime numbers are only divisible by themselves and 1, okay? So prime numbers are divisible by themselves and 1. So for example, 2. 2 is a prime number because only 2 and 1 go into 2. 3 is a prime number. 5 is a prime number. 7 is a prime number, 11 and 13 are prime numbers, 17 is a prime number, 19 is a prime number, 23 and 29 prime numbers, 31 and 37 are prime numbers, 41, 43, 47 prime numbers. You don't need to know much more than that when it comes to prime numbers. But I would say at least being comfortable with the first line here, right? And then you can figure out if you need to know the others later. But knowing what prime numbers are is helpful because it will help you break numbers down and then find two things very important in math. the lowest common multiple, and the greatest common factor. When you know how to prime factorize a number, it helps you to do those things. And I know Mrs. Durham has an activity that will make it fun, and we'll talk about that later. Maybe I'll have her share some more on that. But basically, prime numbers are very important in mathematics, and they actually have applications in real life as well. They are applicable in the area of cryptography, or I would say network security. Network security. In network security, it's very important to understand that prime numbers are used in some of that detail. Okay, we'll talk more about applications in another video, but just know that prime numbers have real application. If you know how to prime factorize well, then you can actually find lowest common multiple, greatest common factor. You can add fractions better, and you'll be able to add fractions better, which is another topic that a lot of students sometimes struggle with. So stay tuned for more information on that. So where do we go from here? How do we prime factorize a number? Well, if you take a number like 28, and someone says you should prime factorize it, you can use a factor tree or a factor ladder. Let's do it both ways. Here's the factor tree approach. The factor tree approach, you write down numbers that go into 28, like 4 times 7. So notice that when I put a multiplication here, for example, we know these two multiply to give me that. 7 is a prime number, so I can't go any further. I leave it alone. However, I can break 4 down into 2 times 2. So 28 is 2 times 2 times 7. Notice that 2 is a prime number, 7 is a prime number. So we're good. Okay, how about the factor ladder? Here's what I grew up with in Nigeria. We used a lot of the ladder. This is one area where it's nice to know both because you can use whichever one you need to be efficient. 2 goes into 28 14 times. Okay, so 28 divided by 2 is 14. This is how I use the ladder system. 14 divided by 2 again will give you 7. 7 divided by 7 will give you 1. You take 2 times 2 times 7, that gives you 28. You've prime factorized 28. 28 is 2 times 2 times 7. Some people might write it like this. Again, the dot in between is for multiplication. When you get to algebra, you'll find out why we do the dot. This is the prime factorization of 28. 2 times 2 times 7. When you write a number squared, it means that you're repeating this value multiplied by itself. Okay. So, prime factorization, great tool. We're going to spend some time there. We're going to talk about divisors of numbers in your work. We're going to talk about divisibility rules for 2 and 3 and maybe 4 and 5. 5 just is, if a number is going to be divisible by 5, you have to be able to divide that. I mean, that number needs to end with a 0 or 5 in order for it to be divisible by 5. In your assignment document, there's actually something called the sieve of Eratosthenes. The sieve of Eratosthenes. If you write the numbers 1 to 100 on a piece of paper, you can actually use that to find the prime numbers from 1 to 100 using the sieve of Eratosthenes. Okay? Stay tuned for that video. We'll make a separate video going into detail on that. But basically, if you take a number like 2 when you do this exercise, you would cancel everything that is a multiple of 2. So you write 1 to 100, you take 2, you cancel 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Cancel everything that is a multiple of 2. Then you take 3, you circle it, and you cancel everything that is a multiple of 3, which some of them have already been canceled. You write 4, you cancel everything multiple of 4, and so on and so forth. When you finish with the sieve of Eratosthenes, you will only have numbers, the numbers that are circled, will generally be the prime numbers. Okay, there's a lot to chew on. We'll be talking more about prime factorization and prime numbers. You're going to have multiple days to work on this. Keep refining your arithmetic skills. Keep up the good work. That's what matters. We'll be talking soon. Take care. Keep up the good work. And by the way, prime numbers goes back to a man named Euclid from about 300 BC. He wrote a book called The Elements of Geometry. That is a book we have at our school. You can read it for fun. We have the English and Greek version. It's good to go back in math history. We'll talk about that in another video. Take care. Have a blessed day. We'll see you in the next video.